Hello, this is Tim here from AACC. I hope you're keeping well. This is hopefully a first of a series of RobotStudio tutorials for the mechatronics students. So this is the first one. I'm going to hopefully create about 3 of them, and it's just a video based on this Industrial Robotics Lab number 1. You're going to have this document, and it should hopefully go step by step and kind of show you how to program our ABB industrial robot. You know, I think it's good to have a video as well, so that's kind of what I'm going to work through. So you're going to use a program called RobotStudio. So what is RobotStudio? It's something called offline programming. It's a graphical tool to program our industrial robot. So let me just open something up here, and it'll be easier to kind of explain. So what I'm going to give you for your lab is you're going to get this document, and you're going to get this file called MechStation Ultra Final. Let's do this. Let's rename that and give that a decent name. Let's call this AACC Industrial Robotics Robot Lab 1. There you go, that's a bit better. So you're going to get this file, and it's a RobotStudio Pack and Go. So instead of you creating a workstation and creating a robot from scratch, we've put this file together, this kind of tutorial together that has the robot, that has all the parts, and it's kind of ready to go. It's kind of a nice you can kind of play around with it and get your hands on it instead of going step by step. We are going to go through this step by step, and we're going to create import a robot, import parts, build the table, do all of that. But this is just the first thing, just to play with. So I'm going to go to open, and I'm going to find this file, this RobotStudio Pack and Go business. And I'm just going to import this, and let's just have a look. So what I'm going a bit faster. All it's saying is, look, let's go back here for a sec. Do you want to unpack this? Do you want to unpack it? Yes, we do. Where do you want to unpack it? Just unpack it to a folder on the desktop if you want. It really doesn't matter. And I'm just going to go yes, and then I'm going to go next and next. I don't really care about all of this. So you're going to unpack this file, and you're going to see something will come up now in a second. I haven't forgot about the question, about the RobotStudio question, like what exactly is it? There's 2 main ways that you can program a robot. You can use the actual teach pendant, which is the little the handheld device that's next to the robot that has a screen and a joystick, and you can manually teach the robot or program the robot using that. That's one way, and you can really do an awful lot with that. Another way is using this offline programming business, and so the offline programming business is this RobotStudio business. So you can see here that we have a nice 3-dimensional model of the robot. Essentially what I'm going to do is I'm going to interact with this robot and these objects and different things, and press buttons, and what it does is it outputs something called rapid code. Now let me show you what rapid code looks like. This is what rapid code looks like, and this is essentially what the robot wants. This is what the robot uses to operate. So essentially we use RobotStudio to move around and train it and say, remember this point, move to this point, and turn on the vacuum and whatever and so on. And when we're done with all this offline program malarkey, what it does is we can generate this code. And it generates this code, and you can see this. Look at this: while, true, if, end, if, set. It's based on C programming. So hopefully at the end of the tutorials you'll have some concept of this rapid code business. This is a proprietary ABB programming language. This would be a nightmare to have to program the robot with. We use RobotStudio. Okay, so it's an offline, it's a graphical programming system, and what it does is you know, we don't need to. I'm in my house right now, you know, 15 miles away from the robot, and I can do all this programming here, and I could email this to Elliot or email this to one of you guys, and you could take my work and you could program the robot. So I can program this offline. The other advantage is typically a robot will be in an assembly line, and we want to keep that assembly line running. And if we want to make some sort of changes, we'd like to do it offline, you know. So this is definitely the way of the future, and the most common offline robot programming system is RobotStudio. So yeah, hopefully that's kind of helped you. Now, when you import this pack and go business, it's going to ask you a question. It's going to, do you want to detach this from the current holder? You're just going to say no, okay? So just say no. And here we go. Now we can play a little bit. So this, what does this look like? This is our table at AACC. There's the position of the robot. What is this? This is the vacuum chuck with our what is this called here again? This is the vacuum chuck, but what is this? This is just some sort of like rubber gripper. That's probably not what it's the proper term for it, but it generates a vacuum and it just sucks it in. We used to use a claw or a hand end effector, and it was way too difficult to use. What we're going to do in this lab is we're going to pick up these simple metal pucks that we have in this plastic piece, and what we're going to do is we're just going to shuffle them around the place. We're going to pick them up, move them about, and shuffle them back and forth. Now let me just show you what I can do. What am I doing here? I'm zooming in and out here with the mouse. Now I can zoom into a certain point and I can zoom out. I'm just using the roller ball of the mouse. Okay, if I hold down the control key and the left mouse button, I can pan. Okay, so control and the left mouse button, I can pan, and then I'm holding down the control and the shift key and I can rotate around the place. Okay, so that's just shift and control. Now let's do a couple of things. I want you to practice that, and then up here it says freehand, and the first thing I want you to do is I want you to highlight, and I want you to say jog linear. Now before I get it, let's just relax for a second and let's look at these joints. This is a 6-axis robot, so there's one joint there, there's a second joint there, there's a third joint there, there's a fourth, there's a fifth, and at the end of this can also rotate. So we have 6 axes of movement, and what we can do is I can grab this jog linear, and I have to click on one of these parts of the robot, not the vacuum chuck, and then we have these arrows here. So I can grab hold of the highlight over the red arrow, and I can move this, and look how the X is changing. No, yeah, I'm glad this is actually in inches. So X is changing, minus 13 inches there. So I'm just moving this back and forth, and this is actually how the robot would move. Then I'll bring it over here to the right a little bit. Then I'm going to grab the green, and I'm going to move the Y back and forth. And then I'm going to move the Z. And you can see will it actually, let me see if there's a crash into the table. It probably does. It'll go straight through, but that's the limit that robot can really work with. That's its working, I think it's called its working envelope. Now, that's it. Alright, what's next? Let's have a look at these tabs here at the top. We have File, Home, Modeling, Simulation, Controller, Rapid, Add-ins and Modify. The main ones are really Home is where you're doing about 90%, 80% of the majority of the work, and then you have Modeling and Simulation. So let's just look at File here kind of quickly. File, we can save as, we can open, we can close. The other thing we can do here is down to Options. I can go to, this opens up this Options dialog box, and I can go to Units, and I can change, like the different types of units. So a length, I want this to be in inches. You know, that's really the main one. I want to work in inches, you know, so I'm more used to that. So if you guys want to work in centimeters and millimeters, that's fine too. So let's go to home. So you ABB library. So typically what you do is the first thing you will do is you will import a robot, and typically, you know, you're going to import the type of robot that you're working on. So if I can find here, I can open this ABB library, and I have all these different types of libraries. I have a spider robot there. I have big, massive, humongous car factory picking up big things, IRB 7600, and then right at the very top here we have an IRB 120, which is their smallest industrial robot, okay? And it's becoming very common. So we can bring in a robotic system this way. The next thing is we have an import library. We can import different types of equipment like conveyor belts. If we want to show where the controller is, I can do that too. I can import pallets, different types of end effectors, tools, all that type of thing, welders. These are the very, very common type objects. And then you have all these training objects that you can bring in. You know, what you can do here, this is a robot, but instead of bringing in a specific robot and a specific controller, what you can do is you can bring in the robot and the controller, and typically you would use this robot system over the ABB library. That probably doesn't make a whole lot of sense, but we're going to do that later. You can import, you know, these pucks here that you see here are from our Festo MPS. This little holder that Elliot designed, we would have imported these using the import geometry. You know, so if you want to build geometry, or you want to build, like, give you an example, we would have imported this tool here, this vacuum chuck. But if you want to draw something up in SolidWorks, you can save it. You can import SolidWorks files, but you don't import a SolidWorks file, you import it .sat. So .sat, you know, is a standard CAD format, and you know, within SolidWorks you would save that as an SAT file, and then we can import it as an SAT. So hopefully that makes sense. What we're going to be doing is we're going to be creating targets. So we want this robot to move around certain points, move to certain points. These are called targets. And then once you have a collection of targets, you're going to create a path. So these two commands here are very, very important. You have you can jog joints here, stuff like this. I've kind of gone over that a little bit. And let me see. It says motors aren't off, so I'm going to have to figure that out. So why won't that move? I'll figure that out in a second. What else? Down here, so this is our table. This is our robot. Below our table we have a big massive controller that controls the robot. Now what RobotStudio has, it has something called a virtual controller. So instead of I'm just working at home here on my laptop. I don't have a controller, but what I have is this virtual controller that acts identical to it, you know. So this is actually a real program controller that's controlling this robot. Probably doesn't make a whole lot of sense, but I'll kind of get into that later. Now what else? I have these two tabs here. I have a layout and I have paths and targets. My layout, I can click on puck, and you can see these are the components that I'm after importing. I have the vacuum gripper, and then I actually have the robot itself. So this is it's kind of like your assembly tree in SolidWorks. And then I can click on paths and targets, and I can see here that I don't actually have any targets defined yet. Okay, so there's no targets defined. You would see them there. So that's just a little background. Now what else do I want to show you? Yeah. So also, there's an awful lot of lines and curves and geometry that we need to select. And what you can do here is you have on the top of this frame here, you can select, if you want to just select a surface, I can select a surface. If I want to select an object, I can select an object, and so on. Typically it's going to be just surface, and then I can have this. This is similar to the snap in AutoCAD. So at the moment it snaps to the center points, like so. I don't know if you can see that. Then I can what is this? It says for snapping the cursor to the closest center, mid or end point. So this is kind of like the quadrants. So you can select an awful lot of different points that way. If I had lines, watch this, let's say I want to select this end of line here. I can just get an end point, and that pops up there like that. So these are very, very useful. Let's say I want to measure the length from the center of that puck to the center of that puck. Let's turn on this snap center business, and then I have a ruler here, point to point, and I can select there, and select there, and it's 2.36 inches. Okay, so the plan is, I'd like to pick up this red, I want the robot to pick up this red puck. I want to place it on the table. Then I want the robot to pick up this puck, move that over there, and then move this puck over there, and then go back and get the red puck and put that in this slot. So we just want to move the pucks around, that's it. Before I can do that, I need to create some targets. So how do we create targets? I'm going to click on this target button right here. Okay, and this, hopefully this comes up. It might be docked, and if it is well, if it's docked like that, it's not a bad thing. What you can do is you can grab these boxes or this frame, and you can dock this wherever you want. But essentially I want to see this whole menu. Okay, so I think you actually have to click on add new first, and then I'm going to zoom. Is it going to let me zoom in? No, I'm going to press escape, and let's try that again. Let's zoom in here a little bit first, and then click target, and then click add new, and I make sure that I have my snap center on, and I'm going to click there, and then I'm going to click there, and then I'm going to click there, and I'm making sure that I get the center of each puck, and you can see points 1 to 3 have come up. And what's happening here is this inch here is changing. Now I'm going to go create, and what happens? Then I'm going to click close, and on the left hand side here in paths and targets, I have target 10, target 20 and target 30, and they come up. So I'm after creating 3 targets. Now I have a feeling that takes a little bit to get the hang of, and you're going to probably, don't worry about putting up your hand a few times because it's a little bit of a pain. Okay, so that's next. What's next? So I have the 3 targets, and what I'm going to do is I'm going to create some, this will make sense in a bit, but what I need is I'm going to create some offset targets that are above these targets, that are maybe 2 to 3 inches above them. So what I can do is I can right click on target 10, and I can press Control C and Control V. And then what I'm going to do is I'm going to right click here, and I'm going to go rename, and this will make sense in a little bit. I'm going to go target 10 offset. Right, now there are 2 targets right there, and what I'm going to do is I'm going to just move one of them up. So I'm going to right click, and I'm going to go modify target offset position. Okay, there we go. Now red is X, green is Y, and Z is blue. So I'm going to translate that. I'm going to move that up 3 inches, and that's where it's going to be. And I'm going to go apply. And there it is. Now I have a target that's there, a target that's a little bit above it, and I'm going to do the same, and this will make sense in a bit. I'm going to right click, I'm going to click here and go Control C, Control V, and go rename and call this offset. And then I'm going to go modify target offset position. I'm going to do the same with this one. I know that it's blue, so I'm going to make it up 3 inches. I'm going to go apply and close. Click here, Control C, Control V. All I'm doing is copying it. I'm going to go rename, offset. Beautiful. And then I need to go offset position. Right. I have 7 targets. Now this home target was, I don't know, did Elliot put that in, or I think that was there already. So we have a home target, and then I have this target, that, and that. Let's have a look. Okay, so I'm going to right click on target 10, and I'm going to go view robot at target. Okay, and that's what the robot wants to, when it's there, That's how it wants to orientate itself. And that's actually going to work just fine for us. What you can do is I'm just going to leave that the way it is. Okay, I'm going to right click on that target and I'm going to go to configurations, and I'll explain this in a bit now in a sec. And basically this configuration pop-up opens up, and it's basically saying, look, if you want this robot to be touching at that point, there's only one configuration, and this is how the joints would be set up. I would need to show you another example of that to really understand this. Unfortunately, there's only one configuration. If there was multiple ones, it would make a little bit more sense. But basically, I'll explain that later. So I'm going to go apply, and notice how there's no inverted commas here. The configuration has not been verified. So this one is happy. So I can click on home, and that's what the robot is there. I click on target 10, and that's what the robot's going to do there. I'm going to right click here again. I'm going to go configurations, and there's only one configuration. I'm going to go just apply. Alright, let's have a look. I'll do the same with this, and there's only one configuration, only one way that all these 6 joints can reach that point. And I'll do the same with this one. I might be able to do multiple ones, so I've selected 2 of them. Yeah, there's no way you can do multiple ones. So I'll just go through them. That's it. Okay. So let's say we want to create a path, and we want to go from home to target 10 offset, and then down to target 10, and then back, and so on. Let's do that. How can I do that? Come on now. Let's right click and go view all. I'm going to click on path, and I'm going to go create an empty path, and I have a path here. I'm going to drag this home target down, and then I'm going to drag target 10 down. Then I'm going to drag target 10 offset down, then target 10 down, like so. So it's going to go home, then it's going to go to target 10, then it's going to target 10 offset, then target 10, and then I'm going to go back to target 10 offset, and then I'm going to go back to home. So I have just a cycle, and you can see there by the yellow line, that's showing us the path. Now notice that it says this move L. Now that's called a linear movement. There's 2 types of movement in robotics. There's a linear movement, and there's a joint movement, and I'll show you the difference. So in order to work this, I'm going to right click, and I'm going to go to configuration. I'm going to click on auto configurations for this path. Okay, and I'm going to right click on that, and then I'm going to go move along path. And what it's doing is it's opening up this controller, and it's actually seeing that it can do it. Okay, and it has no problems doing that. So what it does is it has to calculate every point along that, or most points along that line I'm going to say to a point. And it calculates most points along that line, and then it actually does it. Now let's say if I want to change all of these, let's say I want to change that to be a move J instead of a move L. I'll right click on it, and I'm going to go modify instruction, and instead of it being a linear motion, I'm going to make it a joint motion, and let's look at the difference. And now I'm going to go, I think I'm going to have to auto configure it again. Now let's go move along path. Okay, now let me just show you a little bit let me show you what's going on here. Instead of it going along the entire line, all I wanted to do, and it's funny enough, look at this point here seems to be a little bit higher. So I'm going to go back and change that. I'm going to right click on that, and I'm going to go modify target offset, and it looks like I need to bring it down 1 inch. There we go. And then I got to configure that again. Okay. So let's run this path. And let's look at it when it moves. It's not going to follow that straight line. It's just going to curve around it. You'll see. Watch this. Okay? So what does it do? It starts there. It goes to there, but it just bends around. And it's actually less work for the robot. Just all you're saying is you start there. Anyway, the robot can get to this point. You do it. And what it will do is it will just do the minimum amount of movement. It doesn't have to calculate each of these points. So whenever you have a move L, it needs to know where all of those points are. A move J command is saying, look, that's your start and that's your stop, your end point. You get whatever way you want. The quickest way, so it'll just bend around it. Let's run it again. And let's look at it. Notice that it doesn't follow the line. So we have paths, we have targets, and we have paths. So just give me a break for a sec. Okay, I still need a point here, a target where I can swap or I can put these pucks down. So how can I do this? I'm actually going to right click on this path and I'm just going to delete it. I still have more targets to get. And what I'm going to do is I'm going to get a temporary target using the position of this holder, and I'm going to offset it out about 6 inches. That's my plan anyway. So how do I do that? So let's go to target. I'm going to click on add new, and then I'm going to go snap to the midpoint. I'm going to zoom in here, and I don't know how well you can see that, but it's snapping to right there where I want. And it was just, is it working? Let's try that again. There we go. If you click on add new and you click somewhere and you still see 000 here, it means it hasn't gotten it. So what I typically do is I click on add new again and I'll get it, and then I start to see numbers here, and I'm good with that. So I'm going to go create, and now I have a target there, and what I'm going to do is I'm going to right click on this target 40 and I'm going to call that swap underscore position. Now I also think you can't use spaces when you want to define these targets. Now I'm going to move this, I'm going to modify the target and I'm going to move it in the X direction. So I'm going to minus it over there a little bit, about 6 inches, and I'm going to go apply. And look at this. What's going to happen here is it's going to grab that puck and it's just going to drive it into the table, and my vacuum chuck is going to get all bent up. So I need to move this up a little bit. Now, what are the thicknesses of these pucks? Now, the thickness of the pucks is 23 millimeters, says Elliot. Now, what am I going to do? I'm going to go here and I'm going to go and I'm going to find out what 23 millimeters is. So it's 0.90 inches, and I'm going to offset that. So I'm going to go modify target, offset position, and I'm going to go in the Z direction 0.9. I think I'm going to just make it 1 inch. No, see, I'm after doing that twice. Can I undo that? Yeah, I'll just leave it there then. Okay. So, hold on for a sec. Let's have a look at this. That's up too high. So let's right click again, modify target, offset position. I'm going to bring it down 1 inch. And there we go. Okay, so there's my swap position, and I'm also going to have an offset swap position. So I'm going to click here, Control C, Control V. I'm going to, can I rename that? That works. And I'm going to go to modify target, offset, and I'm going to bring it up about 3 inches. Like so. Okay, and I'll do the same. I'm going to right click here, I'm going to go configurations, and I only get one configuration here. Go apply, and I'll do the same with this, configurations, Let me see, can I give you guys a good, let me see if I can find a good explanation of a RobotStudio configuration. Well, let's try getting it going to the help. Okay, I'm just looking here. Robot axis configurations. Targets are defined and stored as coordinates in the work object coordinate system. When a controller calculates the position of the robot axis for reaching the target, it will often find more than one possible solution to configure the robot axis. Now, this is a good image, but the resolution is pretty crap. So let's have a look. We have a robot, we have a tool, and it's pointing at a propeller. And you can see that's one configuration. The robot can also point there, and it can do this configuration. So it's kind of hard to see what are the differences yet. You can see the difference that this robot is rotated 180 degrees. So this robot has 3 different configurations. Now, each one of them works, but this looks to me the most optimum configuration right there, you know, but each one of these would work. So we have multiple configurations. In our example, the robot has only one way of getting to this point. I'm going to do another videos. You're going to see multiple configurations, and that will make a little bit more sense. Okay, so what's next? We have all our targets. So let's do this. I'm going to go to path, and I'm going to go, and I'm going to drag this home out to path. What do I need to do? I need to create a new path, an empty path. So I'm going to drag out home. Okay, I'm going to go to target 10 offset. Then I'm going to go to target 10. Go back to target 10 offset. Now let's see. Let's try that again. So what I can do is I can drag these move commands up and down. The first one I want is home. Then I want to go to target 10. Then I want to go to target 10. And then I'm going to go to target 10 offset. I'm probably confusing the hell out of you right now. And then where do I want to go then? Then I want to go to swap position offset. And then I want to go to swap position. And then I want to go back to swap position offset. Now why did it do that? Let's undo that kind of quickly. There's the first, there's the second, third, fourth, fifth, sixth. Let's get rid of, we don't need that target there. Okay, there's to there, and then we want to go back to home. Okay, let's just check it. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what do we want to do here? Here we just, okay, the robot starts, then we go to here, then we go to there. What we want to do between target 10 and the next one is we want to turn on the vacuum chuck. So we need to turn on the vacuum chuck somewhere around there to pick up the part. And we want to keep it on. Then we lift up the part, then we go to here, then we go to here, and we want to turn the vacuum chuck off. So it drops the part, and then we go to here, and then we go to here. But let's not worry so much about the vacuum chuck turning that off for a second. So here, this path 10 has all my commands, move L. For the time being, we're just going to work with this move L business. Linear movements, nice simple linear movements. Sometimes when you do this though, if you have a big long straight line, what happens is the robot needs to calculate each point along that line, and sometimes it's doing these calculations and it gets a bit, it's saying for whatever reason. So essentially the robot needs to calculate, it needs to find out the positions of 6 axes at each one of those points. Now just think about what I'm saying there. So for at each point along that line, it needs to calculate the positions of 6 of these joints. That's kind of some big calculations. And what happens is sometimes it finds a point along the line, and for whatever reason it can't calculate that point. Probably doesn't make any sense to you. Hopefully your brain is saying, well, screw the move L command, why don't you just use a simple move J, a move joint, where you just give it the start and where you get it, give it the end point. And that's one way you can do it. The other thing you can do is we can tell the robot that, look, we can say program essentially some forgiveness. We want you to start here, we want you to follow this line down to here. At some point, if you reach an area or a point along this line that's driving, it's very, very hard to calculate, get it as close as you can. And the command for that is, it's called sing area. And what I'll do, and let me show you how to do it. I'll right click here and I'm going to go insert action instruction, and I can find it here, sing area default. Now, so this sing area default, what we want to do is we want to change this argument. I don't fully understand this, but I know that it's useful. So what I do here is I enable this. Is that right? I think so. So I'm going to go enable, and I'm going to go create. And look what it does. Inside this path it goes sing area / wrist. Okay? And it says here, this allows the robot to move through singularity points without causing too many problems. I wouldn't worry so much about this. This is just something that a command that works. I understand how to use it, and it makes life easy, so I would just accept it. Okay. Essentially what this does for us is, if there's any point along that line that the robot cannot calculate, it builds in some forgiveness. Okay. If I take away this command and I try and run this, the virtual controller tries to run the robot, sometimes it kicks out a warning or an error to say, look, one of these points along this line is too hairy, I can't calculate it. And what we're doing here is we're just building in that forgiveness. So I hope I haven't beaten that to death. Okay, that's it. So what do we need to do? I right click here, I go configurations, auto configure. And once it's not running the path, what it's actually doing is it's just checking everything there, and it seems to work. I'm going to right click here and I'm going to go move along path. And what it does is the controller starts working, and I don't know if you can see this output. Okay, now let's run it again. Okay. So what I want to do, I want this gizmo, this vacuum chuck to reach there, and I want it to chill out for a second or two. So what I can do is I can go right click, insert action instruction, and I can go wait time default. So I click on wait time, and I should be able to add a number here, a wait time of, these are in seconds, so I'll just give it 2 seconds and I'll go create, and look what it's doing. It's after adding this to the top. So what I'll do is I'll grab this down to there, so it goes to there, to there, to there, to there, waits for 2 seconds, and then I'm going to add this command here as well, another wait time. So I can just click on it, go Control C, Control V, and I got 2 of them. So let's just check this. Bang, 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 chill out there for 2 seconds, and then move on. So let's right click it and let's go move along path. So it should go back to the start. 1, 2, 1, 2. Lovely. Alright. So what's next? Now we need to turn on the vacuum chuck. So hopefully in class I'm going to show you the digital inputs and outputs. So below this robot is a big massive controller. Now let me see if I can find a picture of this controller. Alright, I think it's called a mini controller. Beautiful. So the controller we have looks something like this. Now, let me see if I can I get into this image a little bit. We have an emergency stop, we have a motor on, and we have the power switch, and then we have these big plugs all go to the robot. One of them, I don't know where, let me see if I can find a better one. An IRC5 controller, compact controller. This works. Now, this controller has a big connector that says I/O. And what we've done is we've done a bit of the work for you. We're after taking that connector out to a breakout or a terminal block that you've used before. Something very, very similar to the Festo MPS. So we have this cable which goes to a terminal block. So we have our own inputs and outputs. So it's kind of like a PLC. And what we've done is we've wired up this vacuum chuck to a directional control valve. If we output a signal to the directional control valve, it turns on the vacuum chuck. If we turn off the signal to the directional control valve, it turns off the vacuum chuck. Now, what I'm trying to figure out which output did Elliot wire to. I'm pretty sure that it's actually digital output 0. 0 is what the solenoid is wired to. So to the direction control is wired to. Now, so essentially we want to turn on, when do we want, let's run through this. We don't want to turn it on there, or there, or there. What we do want to turn on, we want to turn it on right there. So I'm going to right click and I'm going to go insert action command, and I can find that I can do, it's called set digital output. Okay. Now it looks like Elliot has named this signal to be vacuum. Okay, and what we could do is it looks like that's the only signal he's set. This is kind of like the tags that you've already used in your Allen Bradley, your connected components. So he's created a tag called vacuum, and I'm guessing vacuum is going to, let's see if I can actually show you where what the hell does he mean by vacuum, or where can I find out where vacuum is. Just don't, I wouldn't get too confused by this. You don't need to do this. This is just I'm just showing you. Where is vacuum? Vacuum. Okay, where can I find this? Controller, inputs and outputs. Vacuum. It's a digital output. I'd like to know which number this is. DO, value, max value. I'll have to pass on this one. I don't know which digital output this is going to, but to be quite honest with you, it doesn't matter, and we'll have to find out which one it is later. But anyway, let's go back here for a second. Okay. So what do I do? Right here, I'm going to go insert action instruction, and I'm going to go set digital output. The signal is vacuum, and we're going to turn this to be on 1, and I'm going to create. And then it's going to hopefully pick up the puck to there, and then we want to go right click, insert action instruction. We want to set, we want to set digital output default. We want to set this to be 0, turn it off. Okay, let's close that and see what's happening. And I'll right click and I'm going to go move along path. Okay. Believe it or not, that should have picked that object up. We actually have it set up that it should animate, but let's see if I can simulate it. Okay, so essentially I have everything I need. This command, it builds in some forgiveness into the movement. All I'm doing is I'm moving to different targets. I'm turning the vacuum on there. I'm waiting for 2 seconds to make sure that it picks it up. I'm lifting it up, moving it to that position, and then I'm turning it off, waiting for 2 seconds, and I'm going back to home. Okay, so I've built a path. What I'm going to do now is essentially I need to generate some rapid code so we can actually copy this onto the computer. We can copy this onto the robot. The next step I want to do is I'm going to right click on this path and I'm going to go synchronize to virtual controller. And I'm just going to go OK. And what it does is it generates the rapid code, and we can move on to the next step. So the next step is I'm going to go to simulation, and I'm going to go simulation setup. Okay, and this thing opens up. So I have available procedures. I want to add this to the main robot. So I'm going to click on it and I'm going to say add this to the main sequence. I'm going to click on apply and I'm going to click on OK. And I'm going to press play and let's see what it does. I'm hoping it's going to pick that puck up. No. Anyway, it will in real life. Anyway, let's leave it the way it is. This should work. Okay, so I have my simulation, and then I'm going to move over to controller. You could record that simulation if you want, and it would record all of this. In class, I'll figure out why it's not picking up that puck. Okay, and then I'm going to go over to controller, and let's look at this rapid code that it generates. Click on module 1. Give it a second or two. Alright, let's move this down here just for a sec. And this is the code that it essentially gives to the robot. And let's look at it. You're probably thinking to yourself, what the hell is going on here? Now, just like your C programming that you've done, when this program runs, it tries to find the main function, which it does there. And the first thing it sees within the main function, it says path 10. Okay? And what this path 10 is essentially its own function. So what it does, it goes down to main, it says, right, load up path 10. And then it comes here to path 10, and it just, you can actually see the commands that you generated. Move L, home, set digital output, vacuum, and so on. It's very similar to this path and target information that we have here. So let's go back to controller. And then we also have these constants, these robot targets. And essentially these targets are X, Y, and Z positions in the actual relative to the robot. So these are definitions of the robot targets. These are our commands, move L commands and set digital outputs and so on. And what it does is it just runs it sequentially. It starts here, and once that command is done, it just moves on and so on. It just moves straight down. Okay, now how do I get this out of the, how would we move this to the computer? So let me figure that out. So just to be clear, at the moment we have one path. So all that work we're after going through, all it does is it picks that red puck up and moves it to there. You would have multiple, so you would have another path here. You would path 20, path 30, and path 40. We would have another 3. We'd have a total of 4 paths. So we would move this over to here, and then we would move these over. I'm just going to show you how to get one path uploaded to a robot. Okay? So how do we do that? I'm going to click on controller. I'm going to right click on this module 1. I'm going to go save module as. And I'm going to save this as example path 1. Okay? And then I'm going to minimize this, and what do I have? I have example path 1, and it saves it as a mod file. So let me check that's right, save program as. I don't think that's correct. Let's get rid of this and let's go back. I'm gonna instead of this module, I'm gonna right click on this T-Robot 1. I'm gonna right click there, I'm gonna go save program as here. And then I'm gonna save this as example path 1. And let's have a look. So now we have a folder. That makes more sense. So let me show you that again. It's right here. It says T-Robot 1. At this level is where we want to save it. Okay? And if I look in there, I have an example path. It's PGF is really the file that's important. Okay? But what you're going to do is you're going to need the whole folder. Now what you're going to do then is you're going to get your thumb drive, your USB thumb drive. You're going to copy that on to the thumb drive. And then you're going to walk over to the robot and you're going to stick that thumb drive in the robot, and I'm going to hopefully, well, I am going to be around. So let's have a look and see what it looks like. An ABB teach pendant. Now the teach pendant we have looks something like this. And it's not clear, you know, there's your play button, there's your joystick, there's your screen. Around this position of the teach pendant is a little hole there to plug in your USB. You're going to do that, and the next thing you're going to do, and I have screenshots here, is I'm going to be standing there with you, but you're going to load your program into the robot, and let's see how it works. So this is what the screenshots look like. Welcome to ABB. You're going to click on this main ABB button up here at the top left. Okay, and then you have all this, you know, if we just wanted to jog the robot, I would click that button there. You're going to click on Program Editor, and then this opens up. You're going to go to Tasks and Programs. So basically we have an empty program right here, but you're going to click on Tasks and Programs, and you're going to load program, and you're going to find your program on the actual so you're going to find the removable drive, and you're going to load up your example program. It's a PGF file. So you're going to load that up, and then you might have to change the pointer to the main. What that does is it moves the start of the program to the main. Typically it just does that automatically, and all you're going to do then is you're going to press the play button, which is on the start button, which is on the teach pendant, and I'll show you how to do that. So hopefully this guide hasn't been too confusing. We've really been covering an awful lot, but essentially all that matters is you need to know how to create targets. You need to be able to create a path. Once you've created a path, you need to be able to add some wait statements. You need to be able to set some digital outputs on and off. And then you're going to send that to the virtual controller. You're going to test it, and when you're happy, it generates this rapid code, this rapid C code that you see here. And then all we're doing then is we're saving this rapid code onto a thumb drive, walking over to the robot, loading it into the robot, and pressing play. You know, so that's it. You know, that's all you need for the first lab. So if everybody can get if everyone can get the robot to pick up and move the pucks and really practice this Robot Studio and get somewhat familiar with it, we'll be in good shape. So hopefully this has helped you.